Here in section 3.4, we're going to take a look at some measures of position. The first one that we're going to look at is called a z-score. The z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. And really, that description gives us direction as to exactly how we're going to find it. We find it by subtracting the mean from the data value, because that gives us the total distance, and then we divide by the standard deviation. There is both a population z-score and a sample z-score. Even though we calculate them really the same, the formulas look just a little bit different based on the different variables that we use, depending on whether we have sample or population data. If we have population data, then we know that the mean is given by the variable mu, and we know that the standard deviation is given by the variable Greek letter sigma. So for population data, a z-score is equal to piece of data minus the mean divided by standard deviation. And our formula looks like that. On the other hand, if we're dealing with sample data, then we know that the mean is given by the symbol x bar, and the standard deviation is given by the symbol s. So our formula sounds the same, but looks different because of our different variables. Our formula is piece of data, which is still x, minus the mean divided by standard deviation. In each case, what we're getting is the number of standard deviations that our piece of data lies from the mean. If our z-score comes out positive, then that means that our piece of data was larger than the mean, because when we did that subtraction on top, we came out with a positive value. On the other hand, if a z-score is negative, that means our piece of data is less than the mean because we got a negative value when we subtracted on top. Let's take a look at an example. We've got a mean height of males 20 years or older is 69.1 inches and a standard deviation of 2.8. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7 inches. This data is based on information obtained from the National Health and Examination Survey. We're going to find out who is relatively taller. For Kevin, we're going to have to use the information contained in the data for males. So his z-score is his piece of data, which is 83, minus the mean, which is 69.1, divided by standard deviation of 2.8. Put that in our calculator, and we find Kevin has a z-score of 4.96, which is incredibly tall because this indicates that Kevin's height is nearly 5 standard deviations above the mean. Now let's take a look at Candace. So for Candace, we're going to use the information given for females. The z-score here is piece of data 76 minus mean 63.7 divided by standard deviation 2.7. put that into the calculator and we get 4.56 if we round off to 2 standard deviations. So although her height is incredibly tall as well, because she is just over 4.5 standard deviations above her mean, she is not as relatively tall as Kevin Garnett is, because he was more standard deviations above his mean.